Have you ever wondered what pulls us to the ground? Or how this force changes when you're no longer on Earth? Today's podcast will discuss the one force that none of us can escape. Be sure to listen for the question of the day so you can leave your answer in the comments. For the Love of Language and Writing presents Physics, Newton's Universal Law of Gravitation, TOEFL level. What do aching feet, a falling apple, and the orbit of the moon have in common? Each is caused by the gravitational force. Our feet are strained by supporting our weight, the force of Earth's gravity on us. An apple falls from a tree because of the same force acting a few meters above Earth's surface. The moon orbits Earth because gravity is able to supply the necessary centripetal force at a distance of hundreds of millions of meters. In fact, the same force causes planets to orbit the sun, stars to orbit the center of the galaxy, and galaxies to cluster together. Gravity is an example of underlying simplicity in nature. It is a force that acts at a distance, without physical contact, and is expressed by a formula that is valid everywhere in the universe, for masses and distances that vary from the tiny to the immense. Sir Isaac Newton was the first scientist to precisely define the gravitational force and to show that it could explain both falling bodies, which are objects falling solely due to the force of gravity, and astronomical motions, which are the motions of planets, stars, and other celestial objects. His forerunner, Galileo Galilei, had contended that falling bodies and planetary motions had the same cause. Some of Newton's contemporaries had also made progress toward understanding gravitation. But Newton was the first to propose an exact mathematical form and to use that form to show that the motion of celestial bodies should be circles, ellipses, parabolas, and hyperbolas. This theoretical prediction was a major triumph. It had been known for some time that moons, planets, and comets follow such paths, but no one had been able to propose a system that caused them to follow these paths and not others. Gravitational force is relatively simple. It is always attractive, and it depends only on the masses involved and the distance between them. Newton's universal law of gravitation states that every particle in the universe attracts every other particle with a force along a line joining them. Ocean tides are one very observable result of the moon's gravity acting on Earth. Because water easily flows on Earth's surface, a high tide is created on the side of Earth nearest to the moon, where the moon's gravitational pull is strongest. Why is there also a high tide on the opposite side of Earth? The answer is that Earth is pulled toward the moon more than the water on the far side. The water on the side of Earth closest to the moon is pulled away from Earth, and Earth is pulled away from that water. As Earth rotates, this tidal bulge keeps its orientation with the moon. Thus, there are 2 tides per day. The sun also affects tides, although it has about half the effect of the moon. However, the largest tides, called spring tides, occur when Earth, the moon, and the sun are aligned. The smallest tides, called neap tides, occur when the sun is at a 90-degree angle to the Earth-Moon alignment. Tides are not unique to Earth, but occur in many astronomical systems. The most extreme tides occur where the gravitational force is the strongest and varies most rapidly, such as near black holes. A few likely candidates for black holes have been observed in our galaxy. These have masses greater than the sun, but have diameters only a few kilometers across. The tidal forces near them are so great that they can actually tear matter from a companion star. In contrast to the tremendous gravitational force near black holes is the gravitational field experienced by astronauts orbiting Earth. What is the effect of weightlessness upon an astronaut who is in orbit for months? Or what about the effect of weightlessness upon plant growth? Weightlessness doesn't mean that an astronaut is not being acted upon by the gravitational force. There is no zero gravity in an astronaut's orbit. The term just means that the astronaut is in free fall, accelerating with the acceleration due to gravity. If an elevator cable breaks, the passengers inside will be in free fall and will experience weightlessness. You can experience short periods of weightlessness in some rides in amusement parks. And now it's time for our question of the day. Would you ever go on a tourism trip to outer space? Practice your English by going to the link in the description and leaving a comment. If you find this podcast helpful, please leave a rating and review so it can reach more people like you who are working hard to improve their English. And don't forget to subscribe so you can be notified of new podcasts when they come out. Now, back to the podcast. Microgravity refers to an environment in which the apparent net acceleration of a body is small compared with that produced by Earth at its surface. Of immediate concern is the effect on astronauts of extended times in outer space, such as at the International Space Station. Researchers have observed that muscles will atrophy in this environment. There is also a corresponding loss of bone mass. Study continues on cardiovascular adaptation to spaceflight. On Earth, blood pressure is usually higher in the feet than in the head because the higher column of blood exerts a downward force on it due to gravity. When standing, 70% of your blood is below the level of your heart, while in a horizontal position, just the opposite occurs. Some findings in human physiology in space can be clinically important to the management of diseases back on Earth. On a somewhat negative note, spaceflight is known to affect the human immune system, possibly making the crew members more vulnerable to infectious diseases. Experiments flown in space also have shown that some bacteria grow faster in microgravity than they do on Earth. However, on a positive note, studies indicate that microbial antibiotic production can double in space-grown cultures. One hopes to be able to understand these mechanisms so that similar successes can be achieved on the ground. Plants have evolved with the stimulus of gravity and with gravity sensors. Roots grow downward and shoots grow upward. Plants might be able to provide a life support system for long-duration space missions by regenerating the atmosphere, purifying water, and producing food. Some studies have indicated that plant growth and development are not affected by gravity, but there is still uncertainty about structural changes in plants grown in a microgravity environment. In 1798, English scientist Henry Cavendish defined the universal gravitational constant with an experiment that measured the tiny gravitational attraction between two ordinary-sized masses. One result of this experiment was that an accurate value for the Earth's mass could be obtained. This was done by measuring the acceleration due to gravity and then calculating the mass of Earth. The Cavendish experiment is also used to explore other aspects of gravity. One of the most interesting questions is whether the gravitational force depends on substances as well as mass. For example, whether 1 kilogram of lead exerts the same gravitational pull as 1 kilogram of water. In the early 20th century, a Hungarian scientist named Roland von Eötvös found that the gravitational force does not depend on the substance. Such experiments continue today and have improved upon Eötvös's measurements. This article has been adapted from Newton's Universal Law of Gravitation in College Physics by Paul Peter Uron and Roger Heinrichs, published by OpenStax in 2012. Access it for free at the link in the description. To download a free worksheet for this article, please visit lovelangwry.com. That's LOVELANGWRI.com. To get this audio and worksheets for all levels, beginner, intermediate, advanced, and TOEFL, please visit the Patreon page at patreon.com/lovelangwry. Thank you for listening, and happy language learning.